Hello, I'm Mr. Catone from the Math Department. I'm up in room West 305, and I'd like to help you solve 1 Algebra Honors Unit 9 Opener number 13. You see that you have 2 times 10 to the 6th giving you 2 million, to the 4th giving you 20,000, etc. down the line. You might know that 10 to the 0 is simply 1. So 2 times 1 is 2. This here, 2 times 10, that should actually be 20 right there. Somehow that didn't get printed right, but there you go. And then this one, 2 times 10 to the negative 1, 10 to the negative 1 is 1 over 10 to the positive 1. So it's 2 times 1 over 10, or 2 tenths, or decimally it would be 0.2. And you might be seeing the pattern here. 2 million, 20,000, you skipped down by 2 powers of 10 there. So here, it comes down, you're at 2 times 10 to the 0 is 2. 2 times 10 to the negative 1, we're 1 decimal to the left. Now 2 times 10 to the negative 2, if we did it out, it's 2 times 1 over 10 squared, which is 2 times 1/100th, which is 2/100ths, otherwise known as 0.02. And then the same thing here, 2 times 1 over 10 to the 5th. That's 2 times 1 over 100,000th, or 200,000. So that would be 0.00002, because you have tenths, hundredths, thousandths, 10,000ths, 100,000ths as far as place value. And in these particular types of problems, you notice that it's a negative 5 power, so the decimal, you actually have 4 zeros and then the number comes in, so it's to get a total of 5 decimal places to the right of the decimal point here with a negative 5. So here we have, in this problem 2, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros plus this number 1, so you might want to take a guess and say this must be 1 times 10 to the negative 10th. You could also put a decimal point, an imaginary decimal point to the right of the 1, and go backwards until you get to the decimal point of the problem and say, how many spaces did I need to move to the left? And if you count, you would get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 decimals to the left, and so again we come up with 1 times 10 to the negative 10th for the answer to that one. In problem 3, this goes to some properties of exponents you may have learned. So you have 2 items inside the parentheses being multiplied, both raised to a power. That's following this particular principle. A times B to the nth power means that A gets raised to the nth power times B to the nth power. It's actually the distributive property of exponentiation over multiplication, because you are actually raising these powers over this multiplication sign. But that's kind of detailed, as long as you know that when you have 2 items multiplied, 2 factors multiplied together, raised to a power, each one of them gets raised to the power. If this is a plus or a minus sign, this does not hold true. In other words, A plus B to the n is not equal to A to the n plus B to the n. That's a mathematical amateur move if you do that one. Don't ever do that. So now we have A times B to this power. Now notice, one of these factors actually is raised to the power itself. So what if we had that situation? A times B to the t raised to the nth power. Then each of these still holds to this property right here. Each of these gets raised to the nth power. So you have A to the n. And how do you raise B to the t to the n? Well, that property just says to multiply those 2 exponents together. So it's B to the t times n. So let's apply this property to this part of the problem right over here. So we're going to go ahead and do 1.2 to the 3rd power times 10 to the 4th to the 3rd power. And we'll write down the rest of what's over here as well. Come back to that in a minute. So 1.2 to the 3rd power, if we actually do that in a calculator, 1.2 to the 3rd power comes out to be 1.728. Okay, and 10 to the 4th to the 3rd, we should need a calculator for that, because we're going to apply the idea of a base to a power, all raised to a power. You simply multiply the powers. So that's times 10 to the 12th power. So we have all of those multiplied together. And now we have 4 times 10 to the negative 2. If you notice, all of this is just multiplied. There are no plus or minus signs. There's no addition going on or subtraction. So you can simply multiply the things together that are the easiest things to multiply. And I think 10 to the 12th times 10 to the negative second is one of the easiest things to do in this problem because they both have the same base. And you may know that when you're multiplying with the same base, you keep the base of 10 and add the powers. 12 plus negative 2 is 10. And then what we have left is this 1.728 times 4. So in the calculator, that gives us 6.912 times 10 to the 10th. And that qualifies for scientific notation because scientific notation, the first number must be between 1 and 10. And then you have times 10 raised to a power. So this works out perfectly for problem 3A. So here's 3B. Now we're dividing. So let's go ahead and divide out 1.2 divided by 3. In the calculator, 1.2 divided by 3 comes out to be 0.4, 4/10. If we divide these, it's the same idea as when we were multiplying these two up here in this first problem. You keep the base and add the powers when you're multiplying with the same base. And now you're going to keep the base of 10 and subtract the powers because you're dividing. Now be careful, because when you subtract, you're going to do negative 3 minus negative 6. This power minus that power. And so that turns out to be 0.4 times 10 to the negative 3 plus 6. And negative 3 plus 6, you all know, is positive 3. So you have 0.4 times 10 to the third. Now technically, that is not in scientific notation because this number must be between 1 and 10. So if you think of a number there with how I would have to move the decimal point to make this between 1 and 10, I just move it one decimal place to the right, which is essentially multiplying by 10. So if I turn that 0.4 into a 4, and I want to keep this expression equal, that means I just multiplied that by 10, so I'm going to divide this one by 10, which is essentially just subtracting 1 power of 10, making it 10 to the second. So in other words, if you make this factor bigger by a factor of 10, you make this other factor smaller by a factor of 10 so that you have your final scientific notation form at the end. Okay?